Hello students, this is again coming under third unit. Solve the following system of linear equations using Jacobi's method. So there are different methods, you know that. So here you are asked to calculate or carry out only 3 iterations. Okay, only 3 iterations. So that we will see how to do that. So this is the equation given. I don't want to read this. See here, 1, 2, 3, 4. 4 equations are given, and the variables here are x1, x2, x3, x4. So solving this linear equation means you are asked to find the values of x1, x2, x3 and x4. How? Using Jacobi's method. So first you have to check whether the given set of equations satisfy the diagonal dominance property. Diagonal dominance property means, see here, with coefficient of x1 is 10, others are -2, -1, -1. So that means in the first equation, the coefficient of x1 should have the highest value. In the second equation, coefficient of x2 should have the highest value. And in the third equation, coefficient of x3 should have the highest value, and in the fourth equation the coefficient of x4 should have the highest value. So here you see this is called as diagonal dominance. So that is fulfilled here. So only when it is fulfilled we can go ahead. So don't worry, it is given in such a way that the system of equations satisfy the diagonal dominance property. Now you have to rewrite these equations for x1, x2, x3, x4. See here I have written one example. See this first equation here, you see I am rewriting as this 10x1, I will keep it on the left side. All these other terms, x2 term, x3 term, x4 term, I will take it to the other side of the equation. So when you take it to the other side of the equation, see here 10x1 I will retain here equal to this 3 is here. These 3 terms I'll shift to the other side. When I shift to the other side, it changes the sign. So wherever there is minus, it becomes plus. So it becomes this minus 2x2. When it shifts to the other side, it becomes plus 2x2. This minus x3, it becomes plus x3. This minus x4 becomes plus x4. Okay, this is the equation for 10x1. I want only x1. So what you do is this 10 you shift here and you write this as 1 by 10 into, within the bracket you write the same thing, 3 plus 2x2 plus x3 plus x4. Same way you have to do for other 3 equations also. See here I will write the equation for 10x2. 10x2. This 15 is already there. This x1 term, this x3 term and x4 term you shift to the right side. So when you shift to the right side, as I told you, the sign changes. This minus 2x1 here becomes plus 2x1. Okay, minus x3 becomes plus x3. This minus x4 becomes plus x4. So we want the expression or equation for x2, right? So this 10 you get it here and you write it as 1 by 10 into the same 15 plus 2x1 plus x3 plus x4. So same way you can do it for, you can get the equations for x3 and x4. See I have written here. The first 2 I have explained here, third and fourth I have not explained, but the same logic you can use and you will get these 4 equations. Don't by heart, you just have to continue from the given equations. Don't by heart any of this. Now 3 iterations we are asked to calculate. So when you do for the first iteration, there is something called as initial approximation. This initial approximation means this x1, x2, x3, x4 you have to take it as 0. Okay, initial approximation. Since it is initial, I have written this powers here as 0. It is not power actually, it is a representation. x1 to the power 0. It is not exactly power. I am writing this using this notation, which means it is the initial approximation. So what I have to do is, in this iteration 1 I represent as x1. This one represents first iteration. Similarly x2 1. This 1 represents first iteration. x3 1. x4 1. So all this giving me the iteration 1. So what I have to do is, wherever there is x1, x2, x3, x4, you have to substitute it as 0. See, this is what is done here. Understood? So you see this first equation, 1 by 10, 3 plus 2 into x2. x2 you have to take it as 0. x3 you have to take it as 0. x4 you have to take it as 0. See, like this. And you simplify. You get x1 here as 0.3, x2 as 1.5, x3 as 2.7, and x4 as minus 0.9. Now what you have to do is, when you do the iteration 2, all these values becomes x1, x2, x3, x4. Okay. See, initially we have taken x1 as 0, x2 as 0, x3 as 0, x4 as 0. Now when you go for the second iteration, you have to take x1 as 0.3, x2 as 1.5, x3 as 2.7, x4 as minus 0.9. Okay. See here, same thing. Now, wherever there is x1, you substitute as 0.3. Wherever you have x2, you substitute as 1.5. Wherever there is x3, you substitute as 2.7. Wherever there is x4, you write it as minus 0.9 and solve this. Okay. The basic equation is there in the previous slide. So you have to just substitute. So you get these values. Next, for third iteration, what you have to do is, this values what you have obtained in the second iteration, you will take it as x1. See, this 0.78 you take it as x1 here. This 1.74 you take it as x2, 2.7 you take it as x3, and minus 0.18 you take it as x4, and substitute in the original equation. Okay, after substituting you get this. So when you solve this, you will get 0.9 as x1, 1.908 as x2, and 2.91 something, 2.9 something x3, and minus 0.1 something as x4. So finally we have to stop here because we are asked to carry out only 3 iterations. So 0.9 means we'll round it off. All this will round it off to the nearest one. So 0.9, when you round it off, you get 1. So you can conclude x1 is approximately equal to 1. x2 you get as 1.908. So this is approximately equating to 2. And this is 2.9. You approximately say that it is x3 is 3. And this is minus 0.1 something. So that means it is nearing to 0. Okay, nearing to 0. So you got the values of x1 as 1, x2 as 2, x3 as 3, and x4 as 0. So finally you can conclude that like this here. Okay, so very important, very easy here. So thank you for watching.